Good morning, afternoon, evening from wherever you are joining us today, and we welcome back to another episode from Azure Load Testing. This is the sixth episode in a seven-part online series hosted by Bengaluru Reactor team. My name is Rashmita, and I am the event planner for Microsoft Reactor India. I'm here today joined by our very own host, Nick. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speaker will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, thank you all once again for joining us today, and let me bring in Nick into the stream to begin the session.
Hey,
Hey,
Rashmita.
hi Nick, how are you doing?
I am doing fine. Looking forward to another session.
It sounds great. So, yeah, over to you. And
Oh,
I'm also bringing your screen.
thank you. So, as we're waiting for the screen to come up, welcome everyone. My name is Nick Trogh. I'm based in Belgium, and I am a senior content developer at Microsoft, which means that I write technical documentation for our cloud testing services. And while we're just looking for the slides to come up on the screen. So what we will be talking about today is, so as Rashmita mentioned, this is part of a seven-part series about Azure load testing. And so in this session, we will be looking at reliability and building resilient apps. And so looking at how does Azure load testing fit into that end-to-end story about creating
Nick, I'm
resilient
sorry,
apps?
but can you share one more time your screen? Maybe there is some
Definitely.
glitch. Yeah.
Yes. Let me stop sharing. Add it again. Share screen. And there we go.
Yeah.
See if you can see it. It's
Yeah. It's there. I mean, think. Yeah. Okay. There it is, your screen.
Is it up? Yes, it is.
Yeah. Yeah.
Okay.
Okay. Thank you and sorry. Yeah.
No, it's okay. So, as mentioned, so we will be looking at end-to-end reliability and building resilient apps. And in previous sessions, we had been looking at Azure load testing specifically, kind of creating load tests from the Azure portal, also integrating them into your CI/CD pipeline. How does it mix with Azure Kubernetes service? And so today we're going to look at Azure load testing and how it fits into your end-to-end story about building reliable and resilient applications. And so what are we going to cover today? So let's take a quick look at the agenda. So first, we're going to look at some concepts about reliable applications. What are they? What do we mean by reliability and resilience? You've heard me use both words. And so what do they actually mean? And then we're going to dive into kind of what does reliability actually mean in the context of cloud applications. If you host your applications in the cloud, why is there still a need for reliability and resilient applications? Because isn't the cloud taking care of that all for you? And so what are the things that you still need to do? And so that's the reliability of the cloud. And then we'll dive into the details. Kind of the bulk of this presentation is really going to look at kind of what if you build an application? What are the different things that you need to do to make them reliable, make them available at all times for your users? And so there's multiple steps there. So we'll be looking at kind of how do you design an application? What are the things you take into account? Also then, and this is where Azure load testing, amongst others, is going to fit in, is kind of how do you test the resilience and the reliability of your applications with tools like Azure load testing, but also we'll look at Azure Chaos Studio. And then finally, we're going to look at kind of monitoring. How do you make sure that you kind of monitor and get alerted that things are maybe not as you expected, and how do you respond to failures happening and maybe you not reaching your requirements for reliability. And then finally some Q&A, but as mentioned by Rashmita, you can pose your questions throughout the session here in the chat. So welcome all of your questions. So let's dive in. And so reliability, resilience, specifically when we look at outages and failures of applications at certain points in time, there have been some really major issues that you may have experienced, and things like YouTube TV going down for, in this specific case, just for 30 minutes. But if that 30 minutes happens during kind of the football World Cup, that is really costly. And so that amounts to kind of financial impact for the company, for a company like Google in this specific case, or for Amazon or Walmart or J.Crew. All things that happen, outages that happen, and that have either a financial impact, but just as well, they may have other impacts as well. They might even have kind of an impact on people's lives if this is, for example, an application that is being used by first aid responders, and the application is not available during emergencies. You can have really an impact on people's lives. And so outages and their consequences are really tangible. And so why do things go bad? What are some of the reasons why you may have these types of outages happening in your applications or across different systems? And so there's kind of from a high level, there's like three different kind of categories that we can look at. And so one is hardware will fail. At one point in time, things will break, whether that is a hard disk, whether that is a motherboard or a CPU chip or a GPU. Maybe there's some networking cable that's ripped because somebody pulls the cable. And so hardware will fail. And so you may think like for example, a hard disk in your laptop. What was the last time that happened to you? It might take 10 years for a disk to break. But if you have thousands of disks, let's say at the scale of the cloud, one of our data centers, there may be like 100 million disks in there. And so if one disk failure happens every 10 years, multiply that by 100 million disks, that will mean that you will have every couple of minutes, one of the disks will break down at a point in time. And so what we do is we incorporate like redundancies, physical redundancies where possible. So we will have replication of data across multiple disks. We'll have multiple data centers. We'll have things like availability zones, and we'll look into that a little bit later. And so we try to kind of put in redundancies where possible. Next is software. Software will have bugs. Although we all aim to write perfect software that has no bugs at all, they will happen. And so what we try to do is we try to deploy our code changes as cautiously as possible. We do testing, we do unit testing, we do integration testing, we do all different types of end-to-end testing to make sure that we catch bugs in our software as soon as possible. So we kind of minimize the impact of those bugs happening. But still, there's processes and things like continuous integration that can help us remediate and identify bugs as soon as possible. And then thirdly, and probably one of the kind of the biggest one you see happening, is people will make mistakes. Whenever there is a manual process, somebody will make a mistake. If there's multiple steps that you need to go through, you may have documentation. People will skip over steps. or documentation will get out of sync with operational processes. And so what we try to do there is we try to automate as much as possible when we have operational processes or other processes, such that things will happen predictably, reliably each time we run them in an automated way. And so there's ways that we can remediate these failures, but still things will happen and things will fail. Wait a second. So moving on to the next one. And so reliability, why is it important? So reliability is really about avoiding failure. However, that is impossible in the public cloud, or I think even in local deployments or hybrid deployments as well. Avoiding failure is impossible. And so we can aim to kind of create applications that are resilient whenever failures happen, because there's people, there's software, there's hardware that fails. And so you can't avoid every single failure at all times. And so reliability is really about what do we want to aim for? What is an appropriate level of availability for our application? And we'll come to that later, but you'll hear people talking about kind of the 4 nines, 5 nines of availability. What is your uptime requirement for your application? And so reliability is really about what do you want to achieve in terms of availability of our application, of our services in production. Resiliency is really about what are the measures that we can take? So how are we going to ensure that our application can meet that reliability requirement? So what redundancies do we need to build into our application? How do we tackle specific failures? What if a third-party service that we're calling from our application, maybe we'll have a billing component that we need to call from our application. What if that service goes down? How do we remediate? How do we accommodate our application, our user experience, such that we don't have an impact on the end-to-end experience? And so that is what resiliency is about. It's really about the measures that we take. How do we achieve that level of availability? And so that really is, if we talk about reliable applications, resilient applications, it's really about a shared responsibility. So especially when we build applications on top of the cloud, at the bottom, you can see here the resilient foundation is really our responsibility as Microsoft, or as a provider of cloud services. Our responsibility is that we provide you with a resilient foundation of hardware, processes, and capabilities for you to build applications that are in turn reliable. This brings us to kind of the two top components is how can we take advantage of resiliency features in the platform? And we'll see a number of those, so that you can make an application that is reliable and that is resilient. And so kind of the top layer there is your application code. Is how can you build things in your application code that make your application resilient to failure? For example, that might be implementing retry logic in your data layer. So when you're connecting to a database, the database is not there. Maybe there is a transient connection failure. Well, you'll be retrying. And maybe after that retry, the application will work. So there might be a delay for the end user, but they will not be experiencing any downtime, just maybe some performance degradation. And so things like retry logic are kind of one of the things that you can take advantage of in your application. And so looking just briefly at kind of the that foundation, that cloud foundation, that reliable foundation of the cloud that we provide you. So there is, of course, our cloud infrastructure. So all of our Azure data centers and Azure regions that you see there. There's capabilities like storage, replication, redundancy at the networking level, things like, and we'll see a demo of that, things like traffic manager, where you can actually decide and define how your traffic is routed if, for example, one application goes down, to route it to another application, as well as our operational processes and our principles of how we kind of manage a cloud environment such that we aim for the highest possible reliability for you to build applications upon. And so here you can see kind of an overview of our Azure infrastructure, all of the different Azure regions, as well as the different data centers that we have across the globe, all of them connected by fiber and undersea cables, again, making sure that you can build applications that are reliable. All right, taking us to kind of the core part of this presentation, because yes, you have a resilient and reliable foundation on top of Azure that you can build your applications upon. Kind of what are kind of the resiliency features that you can take advantage of, and how do you build your application such that it is reliable for your end users? And there's a number of things that we need to do there. And so it's basically a three step process when we want to build kind of in a structured way reliable applications. And kind of we have a number of articles and quite a huge set of guidance about building kind of defining an architecture for applications on Azure. And it's all part of what we call the Azure WellArchitected framework, or WAF, WAF. Which you see the link here. And so part of that, of the well-architected framework, is all about building reliable applications. And so that structure for building reliable applications consists of 3 steps. And so the first step is really about designing your application. Designing first is about kind of what are our availability needs. First of what are your specific needs? Your application may not be the same as we saw the example there of YouTube, for example, or maybe Walmart. They might have different availability needs than what your application requires. And so really it is about how do we define kind of what our availability needs are for our application, and then taking that information to kind of design an application architecture using the resiliency features of that cloud platform. For example, using platform as a service services that inherently already have a number of those reliability kind of capabilities built within them, but also taking advantage of things like availability zones or deploying an application across multiple Azure regions. So having that redundancy within your application architecture. And so that's what we are going to define in that design phase. The next is really about kind of once we've defined our application, we've designed it, we've deployed it into Azure, how do we make sure that our application is actually meeting those requirements that we defined here in our design phase? So let's say we want to have an uptime of 99.99%, so 4 nines. How do we test that our application is actually meeting those requirements? What are the things that are that may kind of cause our application not to meet those requirements? What are the bottlenecks that you might see there? But also things like what if failures happen? Things like hardware failures, or maybe connection failures. So how does our application kind of go about and deal with those things? And so there we'll look into chaos engineering, which is really about injecting faults into our application, into our system, and then looking at kind of testing how our application is dealing with those specific issues and concerns. And then finally is really about not just testing, but then also continuously monitoring for both the infrastructure, the services that we're using, how are they performing, but maybe you want to add also specific service level or business level requirements that you want to monitor. Maybe you'll have a requirement of number of requests that need to be processed in a given month. How do you monitor those kind of things? And so that's really about operational monitoring, as well as maybe some business monitoring that you want to do as your application is running. So how do you maintain basically your application requirements over time? So diving a bit deeper into our design recommendations. So the design phase, really about defining kind of what are our requirements. And there's a number of things here, a number of acronyms that you may come across when we talk about availability, when we talk about resilience, for applications. And so the first one is what we call an SLI, or a service level indicator, which is basically a measurement. Any kind of measurement, such as, and you see the example here, what is the percentage of user requests that are being processed within 5 seconds? Um, or there might be other specific service level indicators that you define for your application. So you define a specific indicator, kind of percentage of user requests processed within 5 seconds. And then an SLO, or a service level objective, is going to actually use that measurement, so the percentage of user requests, and put an objective there. So what target do you want to kind of maintain, do you want to achieve? So in this specific case, we take those user requests that are processed within 5 seconds. Actually, we want to have that 99% of all user requests within kind of a 1 hour period need to all be processed within 5 seconds. But maybe you have another application, maybe you say like only 50% of user requests need to be managed within 5 seconds, but 90% need to be processed within 10 seconds. And so that could be multiple objectives here, or might be a combination of different values there, or different targets that you define for specific measurements. And then SLA is kind of one that you very often hear in terms of availability, is a service level agreement, is really using that SLO and putting it into a contract, saying that if you don't meet that specific SLO, that specific objective, that target, then basically there is some compensation. Could be financial compensation, could be some other compensation, or some specific action that needs to be taken in response. So it's really making that as a contractual agreement between a provider and a customer, saying like, we guarantee that we will maintain that specific objective. Otherwise, we will compensate you for that specific, for not meeting your requirements. So SLI, SLO, SLA are commonly used terms in terms of reliable applications. And so, as mentioned, there are different needs for different types of applications. So here you could see kind of availability on the y-axis, and so there you can see kind of the what people typically refer to as how many nines does your application support. And so here you have like 2 nines, 3 nines. Yeah, that's is a 9 and a 5, but like here 4 nines and even 5 nines of availability of your application. And so availability is kind of, you can define it. Note that this does not come for free. And just to give you an idea, what does 5 nines? So here you see 5 nines, so 99.999% of the time your application is available. That actually means that you have like 5 minutes, a little bit over 5 minutes of downtime per year, which on a monthly basis is just a very low number. That is less than half a minute of downtime per month that you would have. So 5 minutes. Even here, 4 nines equates to like 50 minutes roughly of downtime per year, which again is like 4 minutes per month. And that is not a long time. And so these are things that you need to take into account. So what does this mean? And so if you then look at what do you need to do to achieve that specific availability, that will have an impact on cost and complexity. You will need to add redundancies. You will need to add different layers of backup in your application. So how much time can you, how much data can you lose? How quickly does a system need to come up if something bad happens? If a data center goes down, how much time does it take for your application to come back in another data center? If it is taking you, let's say, more than 10 minutes, for example, well, already here, you won't be in the 5 nines anymore, because that is 5 minutes per year. If it takes you 10 minutes to kind of fail over to another data center, you're not able to achieve that. And so know that availability comes at a cost, both financially as well as in terms of operational complexity. You're adding multiple components but to your system architecture. composite SLAs. And so you'll see that for the different services that you use, cloud services, but also other services, if you're using hardware in your own data center, each of those components have an SLA, have kind of a target of availability that they have. And so, for example, here, if we look at a web app, an Azure web app, it has 99.95% availability SLA. So if you only use that web app, you will have 99.95% availability. If you add a SQL Server database to your application, so maybe your web app is reading and writing some data in a database, which in turn has 99.99% availability, then the composite SLA, if you combine those two components, that will be 99.94%. So you can see that those two combined will kind of lower your end-to-end availability. And so as you add components, the overall availability might lower, or you need to put in place things like redundancy, in which case you can see here, what if we add in parallel to our SQL database, also we are queuing some transactions. By combining those, we can actually achieve a composite availability that is then, again, 99.95. And so, but again, that adds complexity to your architecture. And so there's means to increase your SLA, but know that an SLA for an application consists of the SLAs for the individual components as well. So it takes some math to kind of calculate your overall SLA. Just so you know, we're not going to do any further math here in this presentation. And so looking at architectures, designing, so you've defined your availability requirements. So what SLA are you aiming for? How much availability do you want to have? And do you want to guarantee to your end users? And then you can put in place different kind of architectures in terms of adding a single virtual machine. Maybe you want to add a data center, use availability zones, or even kind of do failover into multiple regions of the data center. But also on the data side, there are different things that you can do, things that can happen. And so you will have kind of, as you can see here, the complexity of an architecture becomes way more advanced than what you would have for like single component applications. So multiple technologies that you can use. Definitely take a look at WellArchitected framework and the cloud adoption framework in terms of what are the different kind of compute services, data services, but also kind of backup services that you can take advantage of for building reliable applications. Moving us to kind of the testing part of this presentation. And so looking at how does Azure load testing fit into this whole story about reliable applications. So we have defined our requirements. We've built kind of an architecture that hopefully can meet our requirements. So we've defined, let's say, maybe 3 nines of availability. We've built some architectural components. We've implemented, let's say, retry logic in our application code. Let's go. Let's now test if our application can actually meet those requirements. So that's one part. So does it actually meet our requirements in kind of normal conditions? Because there's kind of different different steps in testing for reliability. It's not a one-off thing where you say, like, we've now built an application. We're going to test the reliability just before we launch. And then we're good to go for the rest of eternity, and our application will be reliable at all times. So one is testing under normal conditions. Does our application kind of meet our targets, our thresholds and assumptions that we had in terms of load? What if, and so there, test regularly because our application code changes. Maybe we'll use different infrastructure components as our application evolves. Maybe we're adding new features to the application. And so the complexity of the application changes. So we need to test regularly that our application continues to meet our requirements. So we can test our requirements using normal load, but just as well, we can then validate that our workload performs also under kind of high load conditions. Maybe your application, you have an e-commerce application and load can change dramatically over certain periods of the year. or maybe your application is under high load during the week, but during weekends it will be performing under less load. And so you may have different load patterns for your application. And so those are the things you need to validate as well, not just test for the regular load and regular user traffic, but also make sure that we test for and anticipate for high load conditions and stress testing our application. And so we need to kind of look at peak volumes and also peak load for our application that we test for. And as we said before, humans can be the cause of things to go bad. And so we want to automate testing as much as possible. And so in the same way that we have continuous integration to kind of build our application on each time there's a code change, we can add testing, load testing, simulation testing, peak load testing as part of our automated flow. And so you will have at different intervals, you can integrate your load testing as part of your continuous integration flow. And before you deploy into an environment, you may want to do necessary checks. But then not just testing for load is something that we need to do, because that is assuming that we test for what is known to us. All of the known conditions we can test for. But what if something goes bad that we might not control? What if, let's say, our web application goes down? What if we have, for example, a CPU process on a virtual machine that goes wild and takes kind of 90% of CPU? How does our application behave under those conditions? What if all of a sudden there's some chaos that is injected? And so that's also why we have there. So the one component is really how do we test for load and specific load patterns, the things we can expect. But then also how does our application actually behave once things become less normal, once there are unforeseen conditions and errors that happen throughout our application architecture. And so these are the things that we'll test as well with, and we'll go into a little bit more detail into what is called chaos engineering and chaos experiments. And so testing for load, testing for performance using peak load tests, we can do with Azure load testing. And so throughout the previous sessions, we've given you numerous examples of how you can create a load test for your application, whether you want to use kind of the no code experience from the Azure portal, or you want to reuse kind of your existing JMeter scripts that you upload and run a test in the cloud for. And so you can optimize basically your application at scale. And so looking at the dashboard to identify possible bottlenecks, and then also kind of automating that load testing process in your CI/CD workflow. So we've gone through all of these things in previous sessions, but as a small recap. And so Nikita, who is kind of joining us behind the scenes as a moderator, also kind of discussed the different types of performance tests that you can apply to accommodate kind of normal load, peak load, but then also looking at bottlenecks in your application and what are kind of the long-term effects of running load through your application. And so let's do a small demo for our application and see kind of how do we test our application and make sure that our application is behaving correctly. And so again, I'm going to use kind of the .NET Podcast app. You can find kind of the source code for this demo application on GitHub. And so what we'll do is this, our podcast app allows us to kind of look at different features. So what podcasts do we have coming up? We can sign in and see kind of what are the specific podcasts that are available for me, and so on and so on. We can look at the details of each of those individual podcasts. And so what we're going to do is we can simulate basically a load test that will go through kind of this user scenario of looking at the, and I'll show you here kind of what the test script looks like in kind of the JMeter web interface. And so we can look at the homepage. We can go and look at specific details of a podcast. We can do searches to kind of find, and so we'll have kind of a specific mix of transactions that we want to test, just kind of simulate real user load for. We'll create a test. So I have already created an Azure load testing resource in the Azure portal. And so we'll look at tests. So we can create, let's say, a quick test. So we're going to use the URL. Let's go back to our URL for our application, kind of the home page. There we go. So we'll paste it in. So we'll be using kind of the no-code experience here from the Azure portal. We could say we want to simulate, let's say, 25 users over. We'll keep it short just for the sake of this session, so you don't sit here waiting for 4 hours for the test to complete. And then we could say run test. So we've defined some basic load parameters. And so now Azure load testing will spin up kind of all of the infrastructure to simulate that user load for our podcast application. And so it is now provisioning the infrastructure. So as you've seen, I did not have to create any test script. I don't need to know a lot of details about kind of writing and setting up kind of an infrastructure for simulating, in this specific case, just 25 users. But just as well, we could simulate 50,000 users as well. And so that would take more infrastructure for me to set up and maintain and run my load test for. And so while this one is running, let me switch to one which I have already created previously. Going here into our test runs. And so what you can see here, you will get some statistics about the load test. And so we can validate not only that the test was completed successfully, but that we also defined a number of what we call test criteria, because we want to make sure that our SLA is met for kind of errors happening for users. We only want to have like 10% of user requests failing. Also, we want to have specific requirements in terms of response time, average response time over the application. And so we can add multiple of these criteria to kind of meet or to kind of correspond with what we define as our requirements for our application. And so as we run this test, potentially in an automated way, we can validate that the results actually pass for each of those criteria. And so we can get alerted when specific requests do not meet our requirements. And so here you could see kind of the graphs, and we can just as well, and as we saw in previous sessions, we can start to add server-side metrics as well if we want to dive into the details about performance bottlenecks, for example. So here, created a quick test for our homepage just to check that our application is responding correctly under normal conditions. So let's say we're expecting 25 users to hit our homepage at any given time. Does our application meet the requirements for that? Okay, and so we can have multiple load tests and different types of load tests as well. And so we could have not only that we test the homepage, but for example here, I have one which is running in my CI/CD pipeline, where I will be testing not only the homepage, and we can see it here, but we will have different requests in here. We'll be testing the homepage, the podcast page, etc., search page, etc., etc. And so we can see the response for each of those different types of requests throughout our application. So load testing, really about validating that our application is meeting our requirements at any given time, whether that is for normal usage, whether it's for peak usage, or whether it's for validating that a specific feature is meeting our requirements. All right, so switching back to our presentation here. So we've looked at kind of performance, availability under normal conditions or conditions where we simulate specific user load for our application. Now, what if things happen? We saw at the beginning, hardware can fail. There might be software bugs, and there's human error happening. Um, how can we simulate this? And this is really about what chaos engineering is about. It's really about the practice of kind of, you could see it here, subjecting cloud applications and services to real world failures and dependency disruptions in order to build and validate resilience. So it's really about kind of at random points in time letting things fail on purpose and see kind of how does our application respond to those failures. Because yeah, you might be kind of afraid, why would we want to break something on purpose in our application? Not just for the sake of breaking something, but really about investigating kind of how is our application responding, what is the user experience when something like that happens, um, and how can we remediate. Maybe we need to fail over to another region if it is kind of a hardware failure and our web front end fails. What if our billing service, for which we have a dependency in our core application, what if that dependency is no longer there because of a network failure? Because that third-party provider of billing provider maybe has an issue and their service is down. Should our application kind of fail as a response of that? Maybe we should disable that functionality in our application then if that service is down, but yet homepage, people can still do orders, but maybe checkout of their orders is now disabled. And so these are things that we can check. And so we can create those experiments, that chaos engineering, kind of creating failures in our application to kind of investigate kind of what are kind of the breaking points in our application, and how can we deal with them. So it's really about making things fail, not just for the sake of failing, but then to learn from them and remediate so that next time these things happen, um, we no longer have those failures. And so we'll be injecting faults into kind of our application architecture and making specific components fail. And so you can do chaos engineering at different levels. Maybe for reference, chaos engineering is mostly known from a tool called Chaos Monkey, which was created by Netflix in 2010, 11 ish. So a good decade ago, where when they moved into a cloud environment, they kind of had the concept of kind of why, what if, and why the name Chaos Monkey. Kind of they were like saying like, imagine that a monkey is entering the data center and is pulling cables and breaking things at random. There's nothing that you can expect. That is going to happen. It probably will happen because of the monkey roaming around the data center, and hence kind of chaos monkey. So a monkey entering the data center, creating chaos across the application. And so what can you do as an application developer, as an operations person, to kind of remediate all of those bad things happening? Hence chaos engineering, chaos monkey as the application name they had from Netflix. And so we can have chaos engineering at the pre-release validation, so what we call shift left, so closer to the development and testing phase, versus shifting right. And so in the kind of production validation phase, where we are shifting right in kind of a canary or a production environment. And so where we have, as we are shifting left, we want to kind of do automation and early on in our development cycle, be aware of kind of what is the impact of a failure and remediate that already in the development phase, versus kind of at specific points in time, validating that our production environments or our staging or canary environments can deal with specific issues in a live environment. However, when you do chaos engineering and production, know what you're doing. Make sure that you minimize the impact on your existing user base. Don't just go and throw out, make everything fail. Define clear criteria of when you want to end your chaos engineering experiment, because you are doing those in a production environment. in a testing development environment. You can go much further. And so typically you would have more of those validations. Production validations, be careful because you are dealing with potentially impact on your current user base. And so Azure Chaos Studio is kind of a tool within Azure that you can use for creating chaos experiments. And so rather than just going to the slide, let's do a quick demo of what Chaos Studio is and what it can bring to you. So I'm going to the Azure portal, and in there you could see Chaos Studio as one of the services. You can also search here for Chaos Studio and go here. And so what you'll see here when you open up Chaos Studio is first you'll see here targets. And so targets, or you can also select here onboard resources. Targets is actually it lists basically your different services or resources that you have within your Azure subscription. And if you want to do chaos engineering, if you want to kind of inject faults in those services, you need to explicitly enable those services for chaos engineering. And so, for example, here I have a number of services which are enabled. For example, my podcast web app has been enabled for chaos engineering. Here I have another virtual machine, again, which is also enabled. And so you see here at the right-hand side, you can see manage actions. If we look at manage actions and see what can we do specifically in terms of errors. So for a web app, we can inject a fault which will result in the app service to actually stop for a given duration of time. If we look at this virtual machine resource, we will have different capabilities there. So we can either redeploy or shut down the virtual machine altogether. Maybe we want to create some CPU pressure, maybe simulate a rogue process spinning out of control and taking, let's say, 50, 60, 90% of CPU resources in your virtual machine. Or you want to kind of stop a specific process that is running. Maybe you want to end the web server process on a virtual machine. And so, or you want to do some impact on network, for example. So disconnecting the network cable on your virtual machine is something you can do. And so these are kind of the random kind of actions that you can perform within what is called a chaos experiment. You might see here different capabilities. So there's one is the service direct capabilities, and the other one is agent-based capabilities. Agent-based capabilities are capabilities that depend on a service agent that is deployed within the virtual machine. So the chaos agent needs to be deployed in the virtual machine, and it will act within the virtual machine. The service direct capabilities are something which from the outside, for example, for platform as a service components, it can do performance specific actions without having to install an agent within a component. So for example, the virtual machine shutdown can happen without installing a component within the virtual machine. And so how do we go about and create an experiment? And so let's say we want for our podcast app, which is running here, what we're going to do is we're going to create a new experiment, and we're going to shut down the app service just randomly. Okay, so let's take our resource group. Let's call it shutdown podcast web shutdown. Name is running in a specific region. We're going to use system assigned identity. One thing we'll need to do is then this is going to be the identity that is used to interact with the specific service that we want to imply chaos on. And then we have the experiment designer. And so in here, you will be defining specific steps that you want to happen as part of your experiment. And so here, let's have one step, which is going to shut down the app service. You can define multiple steps in experiments. Steps happen sequentially. So maybe you want to shut down the app service, then you want to add, for example, some networking or some CPU load, etc. So you can add multiple steps, but they will happen sequentially. Then the next thing you could do is you can define specific branches, and those will happen in parallel. So if you want to have multiple actions that are happening in parallel, you would define in a single step, define multiple branches. And so we're going to add a fault in our experiment. So let's see all of the different faults that are available. You can see here the different services that we can apply, the different faults that we can apply to different services. And so here for our app service, we're going to stop the app service. It's going to be stopped for, let's say, for 5 minutes. So you can change the duration here, and then we're going to define specific targets. So which resource do we want this fault to apply to? So we're going to select our podcast web app. There we go. I think that's it. We're going to review. So we'll do a shutdown of our podcast web application. And so this is now in progress. And so that one has succeeded. We can go to the resource. If at any point in time, so this is now our chaos experiment that we see here, you can edit this one and you'll be taken back to the designer if you want to. Let's go back. Oh, let's come back to this one here. And then what we can do as well is we can start or stop this specific experiment. And so if we were to start this one now manually, and note that you can automate this as well as part of your CI/CD pipeline. So if we start this one, you'll see that it goes through a number of steps. It will go to, it's queuing the request. We can go into the details. And you can see as the experiment goes on, you will see the different steps being executed as part of your chaos experiment. So let's refresh here. This might take kind of just a bit under a minute for it to go through queuing, validating all of the different steps, and then applying them. Oh, and one thing which I have forgotten to do is I mentioned that we're going to use a managed identity to interact with our app service, our resource, to inject a fault. It's going to shut down basically the resource. And you can see here, access denied, which something I forgot to do is our managed identity for Chaos Studio, for Chaos Engineering, does not have permissions to interact with our app service. And so that's something that we still need to do here. If we go to our app service here, we go to access control, we need to add a role assignment. So add role assignment. I will now, for the sake of, you can define custom roles, but I'm going to use the contributor because that one can shut down an app service. Then we're going to select who needs to be able to shut it down. And so that was, I think we called it, what was the name of our experiment? It's a name which I have forgot. Podcast web shutdown. That's what it was. Okay, there we go. Apologies for that. So we are going to review. Yes. So we are now assigning the role of contributor to our chaos experiment. So the chaos experiment can now interact with the podcast web app. And so if we go back to our experiment, no, recent, there we go. So it failed the first attempt. If we now start it again, it will be queuing again, and then start basically our experiment. And so what you'll do is you will run these experiments either as part of your CI, so continuous integration pipeline, and then so you start the chaos experiment. So it's doing all of its chaos behind the scenes. And at the same time, in parallel, you will be running your load test. And you will notice then what the experience is. So let me go to the details here. Is as the chaos is happening, you will see the impact as you run kind of your simulation of user load on your application, and you will see that either errors go up or that performance degrades depending on what type of fault you're injecting in there, or that maybe other activities, events are happening to your application. Maybe you'll have some intermittent errors, and then because your database is then being replicated to another data center, maybe that takes 30 seconds. And then after 30 seconds, you can see that traffic is going back to normal during kind of your load test. And so as you are using chaos engineering, you're doing that always, well, mostly in combination with your load tests, where actually you're simulating user traffic, you're running your chaos in parallel, and then you diagnose and you evaluate, you monitor all the things that are happening using, for example, the load testing dashboard. And so you can see that now our experiment is running for 5 minutes. If we now go to our website, you can see that this website is now stopped. Right. So our podcast web app is now down because of this experiment. And if we were to run our load test again, you would see that 100% of our requests would be failing as a result of our web application being down, which makes sense. And so what you can do kind of to remediate these types of errors is that we could go, for example, and look at something that is like traffic manager profiles. And so we could define kind of a traffic profile, which will do kind of priority routing, which means that you define kind of a primary and a secondary kind of region or deployment for your application. And so you will have a primary endpoint and a backup endpoint. And you could see that our primary endpoint has now stopped. And so if we go and route traffic to our traffic manager, it will automatically route to our secondary data or our secondary endpoint, maybe sitting in a different data center. And so our load test or our user experience will maybe have just a few seconds of downtime. But as traffic manager is rerouting to the secondary endpoint, traffic will come back to normal. And maybe you will have met your performance and availability requirements. All right. So here you could see kind of running these experiments, and normally after 5 minutes, this should come back up because our experiment is only running for 5 minutes, and it will then return back to the normal state that we had before, meaning that the web app is going to be still running. All right. So coming back to kind of finally, so we've used testing to validate our application, how it deals with specific errors. We've injected faults. Hopefully, we've done a number of iterations to kind of next time these faults happen, our application will be remediating those faults, and maybe we'll have some redundancy, maybe some retry logic in our application to kind of make sure that those faults don't have an impact on users. But aside from that, we'll also have monitoring for reliability. And so this is where things like the Azure Service Health dashboard, as well as Azure Monitor, where you can define basically your requirements for your application and continuously monitor basically all of the different metrics and resources of your application. We're not going into the detail of that one yet, so that might be for another session. But like, I want to close off as we're almost at time here with kind of a number of resources, the documentation, our blogs, also kind of how do you get started with load testing, but then also a number of links to the well-architected framework, specifically kind of the resiliency section of the well-architected framework. And so with that, I want to thank you. I hope that you've kind of have a better understanding now of what is reliability, resilience, things like SLI, SLO, SLA, that those terminologies are now kind of a bit clearer to you, as well as how you can kind of fit in Azure load testing, but then also chaos engineering to kind of accommodate for kind of load and performance. as well as injecting faults to make your application kind of deal with failures that are going to happen in a better way, so that you can minimize downtime for your users. With that, I want to close it off, and thank you for joining our session.
Thank you so much, Nick, for hosting this amazing session. And thank you all for joining us today. The next session is on 26th September, same time. Do join us. Also, please visit Microsoft Reactor website for more upcoming session. Feel free to use the Learn module link shared in the chat section. Also, right now it's displayed on the screen. This will give you access for to take your learning further. Thank you all once again, and enjoy the rest of your day.
Thank you.
Thank you.